Hello GitHub Universe and welcome to my talk Raspberry Pi Image Customization with GitHub Actions. I'm your host, Gina Häußge. I'm a passionate code monkey, a geek, a gamer, a hobby baker, the creator and maintainer of a nifty little tool called OctoPrint, which will play a role here as slide 1 today, and I'm also a GitHub star. So, Raspberry Pi image customization with GitHub Actions. That's a lot of buzzwords in there, and I thought before we dive into that, I would give you a quick introduction into what is a Raspberry Pi, what images are we even talking about here, customization, why, and so let's dive right into that. A Raspberry Pi is a small single board computer. It looks like this. And it was released in 2012. It starts at around $35, depending on how much RAM you want. That price can increase a bit. And it boots from an SD card, which you, as the end user, flash with a so-called operating system image. And what is an operating system image? That is, or rather, in what shape or form does this operating system image come? So usually it is a Linux system, most often a derivative of the Raspberry Pi OS, which in itself is a Debian derivative. These images come in form of one .img file. They contain two partitions. One is a FAT32 formatted one, roughly 50 megabytes inside, that is mounted on the final image under /boot and contains some kernel configuration files, some overlays, hardware overlays, and depending on the distribution, maybe also a Wi-Fi configuration or something like that. And the other partition is the root partition, ext4 formatted, and that one also gets expanded up to the final size of the SD card on first boot of the image. You flash this image with a flash tool, and these days the biggest recommendation to use is actually the Raspberry Pi Imager, which I've brought some screenshots from with me today. The first screenshot on the back of the stack there pretty much shows you the initial screen that you get when you fire up the flash tool, and it allows you to choose an operating system, choose a storage, so which SD card or which storage device to flash to, and then with a click on write you start the write process, and after everything will just be done and you can boot your Raspberry Pi of that. Note that it says choose OS there, and what happens if you click on that is actually in the front of the screenshot stack, because the Raspberry Pi Imager will give you a nifty little selection with a list of commonly installed and popular Raspberry Pi image Raspberry Pi distribution options. For example, the aforementioned Raspberry Pi OS, but also various more specialized distributions. And where, or rather, how does it get this list of operating systems to offer? Well, the imager calls up a JSON document that is hosted by Raspberry Pi itself, and this RPi imager JSON contains OS list structures like the one pictured here. And if you are a distribution that is being offered in there, then you get your own section basically in this JSON file. And how this works is that the Raspberry Pi imager JSON on the Raspberry Pi side, the one that gets used by the imager tool, will then contain a reference to an endpoint of your own, where a JSON file like this one is hosted, and merge that in then. So what you can do there basically as the maintainer of an OS distribution is maintain your own RPi imager JSON, and the RPi imager will then pull that in as well to offer up during installation, or rather during OS selection. And in such a JSON file, what do we have there? So we have a name of the distribution, a further description, a URL where to download the zipped image file itself, an icon to display next to it in the release date, and then also the size and SHA-256 hash of both the extracted and the zipped image. So this is very interesting if you want to maintain your own Raspberry Pi distribution, because if you control this or can generate this kind of JSON structure for your images, then you can easily serve them up for installation through the Raspberry Pi Imager. Okay, so now we've seen what a Raspberry Pi is and what an OS image is and how you can get them into the OS lists offered up by the Raspberry Pi Imager, but why do we even want to customize an image? Why am I talking to you about some way to do that through GitHub Actions here? Well, it's quite easily explained. You might want to pre-install additional software to an existing image or update software that is already installed on this image. You might also want to pre-configure things. And this is where my role as the creator and maintainer of OctoPrint comes in. Specifically with OctoPrint, we had the problem that OctoPrint primarily gets distributed as a Raspberry Pi OS image, specifically in shape of the OctoPi distribution. And the problem there is that we want to keep the OctoPrint installation that is shipped with this OctoPi distribution up to date, but without having to rebuild the whole image from the ground up every single time. We just want to update one single bit, one single piece of software on the image, OctoPrint itself, and everything else should be left untouched and should not be not run the risk of any additional build hiccups or something like that. Okay, sounds easy enough. Why do I not just do that interactively? You know, like download the current OctoPi build, boot it up, update OctoPrint manually, then create another image from the SD card and ship that. Well, a lot of things happen during the first boot. I already mentioned that the file system gets extended. So if I flash this 700 megabyte image file on an 8 gigabyte SD card on first boot, the whole root partition will expand to take up this whole 8 gigabyte of space. And shrinking that back down is possible, but it's a bit messy and it can go wrong. Then there is also the problem with key generation. The Raspberry Pi by default will generate the SSH host key on the first boot, and this is something that should stay unique and should not leave this one Raspberry Pi image that you flashed ever, basically. And if you now create a copy of it and distribute it, then every single Raspberry Pi booted from that copy will share the same SSH key, which is just a really bad idea for something that should have stayed a secret. And the same, of course, holds true for other keys that might get generated depending on the OS image. So, for example, SSL certificates, or in case of OctoPrint, for example, API keys or password salts. So, as a consequence, we do not want to boot and copy an image because a lot of stuff happens during a boot that means that or renders the image better not distributable. And also, I mean, let's be honest, manually booting up the image and running through a whole set of steps to do on every single release of your software, it's just not fun. We developers, we love to automate stuff, so why not automate that as well? See, I figured you would agree with me here, and this is why I built Custopizer. You can find it on GitHub on OctoPrint/Custopizer. And it is a customization tool for images that allows you, or rather that automatically mounts an image's partitions, then creates a change root inside a QEMU environment and runs scripts inside that change root that you yourself have defined. It is based on the excellent work by Guy Scheffer, who also created the OctoPi image and has built a whole Raspberry Pi OS customization, or rather distribution build tooling called CustomPi OS, and Custopizer heavily borrowed from that in order to do the whole change root magic here. So big kudos to Guy for sharing that and having done such an amazing job in maintaining it over the years. Custopizer is available as a Docker image, so you can simply run it on your own development machine, but it is also available as a GitHub action. And this is how you run it as a GitHub action. This is something that you can simply add as a step in your workflow. And So you tell it to use OctoPrint /customizer at main or at version 1.0, whatever you want to use as a tag there. You define a workspace folder, which should be mounted into the tool runtime. In this case, it is a build directory that I've created in this example workflow. In the GitHub workspace itself, and in that build directory there should be one single file before you start the customizer build, which is called input.image, and this is the image that you want to modify. And then you also give it the scripts directory, so the directory with the modification steps that should run inside the change root via another property. The environment thing that you see there, that is optional, but it allows you to set additional environment variables that should be set inside the change root environment. So, for example, if you want some specific version number to be pushed into some of your build scripts, then this is how you do it. And this is just a JSON structure inside a string with key value mappings for your additional environment variables. Okay, so you have now seen what we are doing here and why we are doing it, and now it's maybe time to take a closer look at how. Tying everything together, basically. So I'm going to show you how I have created a whole GitHub workflow, or rather a small script and a GitHub workflow utilizing Customizer to do what I set out to do at the beginning of this talk, keeping OctoPrint up to date on Octopi. And you can find all this on OctoPrint /Octopi up to date. And I'm going to walk you through all of this now. And for that, I'm going to switch you over to my editor here. Okay, so this is what you will find on OctoPrint /Octopi up to date on GitHub. You will find a scripts folder and also a workflow, a single workflow. So let's first look at the single script that we have here, o1-update-octoprint. And what that does is, so the first lines here, they are just boilerplate. They install some error traps and make sure that the error handling, should anything go wrong afterwards in this script, will be handled correctly by Customizer and cause the build to fail and produce some meaningful error messages for you. The real magic happens here. And what we have here is that the script will check if an environment variable octoprint_version is defined, and if so, it will use pip install. OctoPrint is a Python, a piece of Python software, to install OctoPrint in this specific version. And if no such environment variable is defined, it will simply install the latest version. So this -u here makes sure that it will update from whatever is the latest released thing. Okay, so this is the script. And now, please don't panic. This is the workflow, and it is a bit long because we are doing some rather nifty stuff here. I'm going to make it a bit shorter for now because we don't actually need to see all of this. But first of all, you can it gets triggered either through a repository dispatch on an Octopi release or on an OctoPrint release, or on a manual workflow dispatch. So when I click on GitHub on run this workflow, and then I can define the Octopi version or the OctoPrint version. So what happens here in this workflow? So first we check out the sources, so we have the scripts that we want to run. Then we determine the Octopi version to use. So either I got one supplied through repository dispatch or through workflow dispatch. If so, I use that, and otherwise I will check which one is the latest stable. The same for the OctoPrint version, and those two things happen in rather long scripts, but you really do not need to care about that now. Just take a look at it if you're interested, and otherwise, let's continue. Okay, so then we download the Octopi image that we determined is the right one, and also actually create a build folder and move it into the file input.image. And then, oops, I did not want to do that. I wanted to do that. Then it's finally time to run Customizer. So workspace and scripts, as we saw in the demonstration in the talk. And the environment here, I set the OctoPrint version to env.octoprint version. And you remember that one will get used here by the update script. Okay, so the script runs through, or the step runs through, and we now have a new image with an updated OctoPrint inside. So that gets renamed. Then we gather some additional data and prepare a release, package the image. For that, I use a little composite action, which pretty much just makes sure to retrieve some metadata before it zips the file. So the size and the checksum of the image file itself, and then the size and the checksum of the zip file. Then we generate an RPy-Imager.json snippet from that. So basically, one of the entries that we saw in this list earlier with the name, the description, the icon, and also all of that, using the collected metadata from the package the image step. Then we create and release, recreate a release and attach the assets to this. And at that point, everything has run through, hopefully, and we have an updated image now attached as a new release. So if everything has gone right, then things will look like this. So a new release has been created. It says just created with Customizer here. You can, of course, customize this message as needed. And the image itself, the zipped image itself, has been attached. An MD5 and SHA-256 checksum file has also been created and attached to the release, so people can actually check that what they download is what they hopefully should be getting. And the aforementioned RPy-Imager.json snippet is also attached here. Okay, so a user could now navigate to this release, download it, flash it manually to the Raspberry Pi, boot it, use it, be happy. But our goal is actually to get that into the Raspberry Pi Imager tool, right? So we have the snippet, but we don't do anything with the snippet yet. It is only attached to this release. So what do we do now with that? Well, another custom action comes into play here. So what currently is registered with Raspberry Pi? .org for OctoPrint's, or rather OctoPi's distribution channel, is an RPy-Imager.json location that is hosted on OctoPrint.org. OctoPrint.org, on the other hand, is a static page built on GitHub through GitHub Actions and hosted on GitHub Pages. So a logical solution to getting an updated RPy-Imager.json on every build is just to use a custom action that checks whether there has been a new release on OctoPrint/OctoPi up to date. And this is what we have here defined as owner and repo. And if so, it will just collect the snippets from the release, the snippet from the release, and use it to generate a final RPy-Imager.json here in ./file/rpy-imager.json. And from that moment on, the download will be usable by the RPy-Imager tool. The additional nifty thing here is that you also see that there is a name stable and a name pre-release property there that you can set. And that is because this tool, this action here, will not only check for the latest stable release, but it will actually check for the latest stable release. And if there is a newer pre-release on the repository defined, it will also take the assets from that or the snippet from that into consideration and generate an OS list that contains both. So when people then select OctoPi to flash on their Raspberry Pi in the Raspberry Pi Imager tool, they will see OctoPi stable and OctoPi pre-release with some descriptions to go with it that tells them further information about the version. And if we go one step back, you also see that this release has been tagged as a pre-release because the OctoPrint version that was flashed onto it is a pre-release version, an RC, a release candidate actually. And the action detects that from the name of the release and accordingly decides. That means what we have seen here now is we have done a full Raspberry Pi image customization in about 5 minutes of a GitHub action workflow run. A release was automatically generated from the resulting assets. An RPi imager JSON snippet was automatically generated as well. And an additional GitHub action takes care of merging these snippets from the stable and the latest pre-release into a final RPi imager JSON that can directly be used by the RPi imager framework and served via GitHub pages. And all of that is fully automated, triggers automatically on new OctoPrint releases and soon hopefully also on new OctoPi releases, and is available to end users, or at least will be soon, because currently this whole workflow is still in the final testing, but I hope it will go live by the time Universe wraps up. Thanks for your attention. I hope that was interesting, and I hope some of you will take a closer look at Custopizer and see if it maybe can help you with your workflows in embedded development. And if you have any comments, any questions or the like, then you can reach out to me either on Twitter or on GitHub. I'm Fusel on both. And you will also be able to find these slides if you want to take another look at them under octoprint.org/slides/universe2021.pdf. Thank you.